Hello Chem 1. Today we're going to start Unit 13 where we take a look at solutions and their properties. Let's get started. If we think all the way back to first semester, we learned that solutions were homogeneous mixtures. That means the solute particles within that liquid are so small that they will evenly distribute. Remember, the solute is the thing that's being dissolved, like salt or sugar, and the solvent is the thing that does the dissolving. In most cases in chemistry lab, this is water. There are also several different kinds of solutions. Most of the time when you think of a solution, you think of solid dissolved into liquid. We call these solids soluble. But you can also dissolve a liquid into a liquid, like alcohol dissolved into water, and we would call those substances miscible. And then finally, we could dissolve a gas into a liquid. This is like soda, where we dissolve carbon dioxide into water. Often these solutions will do something called effervesce, where the gas slowly comes out of solution. That's what gives us the fizziness of soda. We could also dissolve a liquid into a gas. This would be like an aerosol or hairspray or perfume. And we can dissolve a gas into a gas. The air that we breathe is a homogeneous solution. There's nitrogen, oxygen, carbon dioxide, all dissolved together. When you smell something that's baking, that's a gas scent dissolved into the atmosphere. Air is always going to be homogeneous. This is really important. What this means is it doesn't matter where you go on Earth and you breathe in, you're going to have some oxygen that you breathe in. If air wasn't homogeneous, you'd constantly walk around wondering if you were going to walk into a pocket of atmosphere that didn't have any oxygen in it, which could be very dangerous. And then finally, we have solids dissolved into solids. This is what an alloy is. We take solid metals and melt them down, mix them together into a homogeneous solution, and then as they cool, they still stay mixed together in even distribution, but they're solid. Let's get into some properties of these solutions. The first thing you need to understand is something called solvation. Solvation is the idea of something that disassociates or dissolves in water. There's a difference between dissolving in water and disassociating in water. When something dissolves in water, that means it's being surrounded by the solvent particles. So when we dissolve salt into water, the Na plus ion dissolves, separates from chlorine, and it is surrounded by the negative end of water molecules. But it also disassociates because that Na plus cation is disassociating or separating from a chlorine anion. So salts, because they have a positive cation and a negative anion, dissolve but also dissociate from each other in solution. So based on those two words, disassociate and dissolve, we can look at different types of solutes to see what they do. Ionic compounds have positive cations and negative anions. Because of this, they will dissolve and disassociate. Not only will they separate from their crystalline structure, but water will surround them in a way depending on the charge of that ion. So look, if you look here, here's a negative chlorine ion, and the positive side of water is surrounding that negative chlorine ion. That's dissolving. You can also see a positive cation of sodium here, and the negative side of water is surrounding it. So because of the polarity of water and because of the polarity of an ionic bonded substance, you're going to get separation, disassociation, and dissolving or surrounding of those particles. Then we get to molecular compounds. These would be covalently bonded structures that typically will not disassociate in water. In other words, they'll stay together as one molecule. So if you dissolve carbon dioxide in water, CO2, CO2 is not going to separate into C and O. It's going to stay together as one CO2 molecule, no disassociation. But they will be dissolved, and typically they'll be dissolved based on their intermolecular forces being broken down. The next thing we want to talk about is the heat of solution. This is the energy required or released when a substance dissolves. Solvation occurs in 3 steps. The first step is the solute particles must separate from each other. So in other words, we would have a disassociation or a separation of those solute particles. The next thing is the solvent particles must separate from each other to make room for those solute particles. And then finally, the solute and solvent particles must attract to each other. You can notice that the first 2 steps here are endothermic, meaning it's going to take energy to get the solute and solvent particles to separate. This is going to give us a positive H plus value. And then finally, when the solute and solvent particles attract to each other, this is actually going to release energy, and therefore the H plus is going to be negative. Then when we add those three steps together, we could get an overall positive or overall negative H plus value that gives us an exothermic or endothermic heat of solution, which we observed in the demonstration in class. This graphic kind of walks us through the three steps. Here we have a solute and a solvent. So the first step that's going to happen is the solute and the solvent are going to need to separate from each other. So you can see that here is step 1 and here is step 2. This is going to require energy in all instances for both steps. So now we have our separated particles. We're going to add them together, and when they come together, it's going to release energy, meaning we're going to have a negative H value. And now we have our solution. Notice in this case, it did not come down as far as when we started, meaning that the overall H plus value for this reaction is positive. What this means is that this solution took on more energy than it released, and therefore this would be an endothermic solution. It's ending with more energy within the system than it started with. So if we take a look at the sum of all three of these steps, this is our overall heat of solution. If the sum of those three steps is positive, we would call this endothermic. That means the system is taking on more heat than it's releasing. As it takes on more heat from the liquid and the surrounding, it's going to feel cooler or cold. These solutes will also be more soluble at higher temperatures because higher temperatures will allow more heat to feed the dissolving process. If the sum of these three steps is negative, the heat of solution would be considered exothermic. This means the solution would give off heat to the surroundings and it would get hotter. Typically, these solutions are more successful at low temperatures so that heat has more of a gradient to exit to. Here's just a quick example of an exothermic reaction. You can see that we have less heat in the system after we are done, meaning more heat left than entered this system. All right, now that we've walked through that, let's take a look at some of the factors that influence solubility. In other words, how can we make something more soluble or less soluble? Solubility is the maximum amount of solute that can be dissolved into a solvent. So if you have salt and water, you can only add and dissolve so much salt before you max out the space in between those water molecules, and you can't dissolve any more salt. So there's really three different ways to think about this. If you can add more salt to this water solution, that means you have not maxed it out, and we would consider it unsaturated. Then, if you're at the maximum, or you've dissolved as much salt as it will possibly hold, we would call that a saturated solution. And then finally, there is a way to make something called a supersaturated solution. This is when you heat up a solvent, and you add a bunch of solute to a high temperature liquid, and then slowly cool it down. And if you don't disturb it, that cooled down substance will have more solute than it should be able to hold at that temperature, and we would call this supersaturated. The reason this works is because solutions or solvents will hold more solute, solid solute, at higher temperatures. This is why in order to dissolve salt into water, you might heat the water up, because it'll be easier to dissolve more salt at that higher temperature. One way that we can see unsaturated, saturated, and supersaturated solutions more easily is using something called a solubility curve. These are graphs that show the relationship between temperature and solubility. Most solutes, specifically solid solutes, will be more soluble at high temperatures. But gases are the opposite. They're actually more soluble at low temperatures, and this makes sense. If you heat up soda, all the carbonation is going to come out of solution because it's less soluble at that higher temperature. So if we take a look here, let's just look at this red line here in the middle of sodium nitrate. This is a salt that we can dissolve in water. You can see that at 60 degrees Celsius, it can hold 125 grams of solute. But at 40 degrees Celsius, it can only hold 105. So since we have that positive slope, that's telling us that at higher temperatures, it's going to hold more solute. But you can also see that some of these lines have negative slopes, like SO2 and NH3. Why is that? It's because they're gases, and gases don't dissolve as well at higher temperatures. In the same way, we can apply our three different terms here. If we are filling this solution anywhere below the line, that NaNO3 line, that means we're unsaturated. That means we could theoretically add more salt to that solution. If we are right on the line, then we are saturated. That's as much as it can hold. And if we heat this solution up to, let's say, 70 degrees and dissolve our maximum, and then if we cool it off to a place that's actually above the line and it's still holding all that solute, we would call this supersaturated. Another thing that affects how well something will dissolve is pressure. This does not affect liquids and solids. Liquids and solids don't compress, so if you put a solution under pressure, it's not going to help a solid or liquid dissolve better. But it does help gases dissolve better. This is why we put soda in sealed, pressurized containers, because that pressure helps keep the gas dissolved. Another thing that helps solutes dissolve better is increasing the surface area of the solute. Remember, dissolving is when water surrounds the particles. Well, if we crush up our solute or make it into smaller particles already, it's going to make it easier for the water molecules to surround those particles, and therefore it will dissolve faster. This is why if you crush up an Alka-Seltzer tablet, it's going to dissolve quicker than if you use one large Alka-Seltzer tablet. There's going to be more surface area for the water to surround those particles. Another thing you can do to increase solubility is agitation. You know this. If you put sugar in iced tea or coffee, you stir it in order to make it dissolve faster. That agitation increases the speed of the dissolving process. And finally, the other thing that's going to affect the solubility of something is its polarity. For this topic, just remember that like dissolves like. Water is a polar molecule. It is going to dissolve other polar things, like ionic compounds, very well. Nonpolar solvents like gasoline or kerosene are going to dissolve other nonpolar substances well. This is why acetone dissolves paint very quickly, because they're both nonpolar. If the polarities don't match, you're going to form a suspension, like when you have oil and water that separate. This graphic shows how ethanol and water over time will mix together because they have similar polarities. But something like hexane and water, no matter how much you mix them, they're not going to mix together because hexane is nonpolar and water is polar. So they will stay in suspension. I hope that gave you a pretty solid background of the different properties that solutions can have and what we can do to increase the solubility of those solutes in those solvents. Complete the activity for today. Let me know if you have any questions. We'll see you soon.